Now we are going to discuss about non-restoring division. Here, this is the circuit arrangement for non-restoring division. It's common for both restoring and non-restoring division. Okay. So, as usual, first you need to initialize the value of register A as 0. Okay. Then you need to store the dividend into the register Q, and you need to store that divisor in the register M. So we have a adder here, n bit adder here, the control sequencer. So like non-restoring division depends on the MSB bit, that is the sign bit of register A. It has to decide whether we need to perform the addition or subtraction operation, and depends on the value sign bit of A, the Q2 bit will be shift after shifting. Here also we need to do the left shift operation. So we see the steps involved in the non-restoring division. First you need to check the sign bit of A. If the sign bit is 0, you need to do the shift operation between A and Q, that is left shift, and then subtract M from A. Otherwise, if otherwise you need to shift and add M to A if the sign bit is 1. If the sign bit is 1, you need to perform addition operation. If the sign bit is 0, you need to do the subtraction operation. Okay, as usual, for subtracting, so subtracting M from A. To subtract M from A, that is A minus M is equal to A plus 2's complement of M. Okay. So depends on the sign bit of A, we need to decide whether M should be subtracted from A or M should be added with A. Okay. Then after that you need to set the Q0 bit, that is the LSB of register Q0. Q, if the sign bit of A is 0, you need to set 1. If the sign bit of A is equal to 1, you need to set Q0 as 0. Okay, this you need to keep on continue till all the cycle has been completed. Once all the cycle has been completed, in the result, you need to check again the sign bit of register A. Okay, if the sign bit is 1, then you have to take the value of A and add it with M. That will gives the remainder. Okay, so at the end, if the A sign of the A bit is negative, that is 1, so you need to add with M to get the remainder. Okay, so I show you one example, then you can clearly understand all these steps and also the circuit. Okay, consider this example. So here the dividend is 1 0 0 0. The divisor is 1 1. This is the divisor. Here you have a dividend. Okay, so come here. So this is these two lines are initialization. Here it is the register A. Initially you have to initialize the register A with 0. Okay, then you have to, this is the register Q. The register Q is filled with the dividend value. Then this is the this is the divisor value. Okay, that is stored in the register M. Okay, this is the initialization. What is the first step? See here, if you need to check the sign bit of A. Okay, okay. So the A is, as we have initialized, it is 0. So what you need to do, if it is 0, you have to do the shift and then subtract operation. So first to do the shift operation. So in the shift, left shift. Okay, so this is here, this is here, this comes here, this bit here. Okay, so it will be discarded. After shifting, you get this as A, then this will be the Q. So you need to then after shifting you need to perform the subtract operation. So subtract a from m. Already I have told you that a minus m is equal to a plus 2's complement of m. Okay, so here I am subtracting. Instead of subtraction, this is the 2's complement of m. So add it with a. This is a. I am adding. So 1 plus 1, that is 10. 0 here. 1 will be here. 1, 1, 1, 1. Okay. After subtraction, this is the result. Now see the next step. If the sign of a is 0, set q0 as 1. Otherwise q0 as 0. Here the sign of a is 1. So you need to set q0 as 0. Okay. Now the cycle 1 has been over. Okay. Now go for the next cycle. For the next cycle, this is the value of a. Okay. Now again see. If the sign of a is 1, you have to do shift and add m to a. See, the sign bit of a is 1. So you need to perform the shift operation, left shift operation, and then you have to add m, not subtract, add m. So I am doing the shift operation. Okay. So this will be discarded. So this will be empty. So after shift, this is the value of a. Then I am adding with m. This is m, right? So 1, 1, 1 plus 0, 1, 1, 1. Okay. If the sign bit of a is 1, you have to set sign bit of a is 1. You have to set q0 as 0. So I have set this q0 as 0 as this sign bit of a is 1. Okay, now this become a. Okay, okay. Now the second cycle is over. Now again check the sign bit of a. It is 1. If it is 1, what you need to do? You need to do the shift operation and then add. Do the shift operation. Okay, it will be discarded. After shifting, this is the a and this is the q. Okay, then you need to perform add operation. Add m. Okay, so 1, 1 plus 1, 10, 0 here, carry here, 1 plus 1 again 10, 0 here, carry 1 here, 1 plus 1, 10, 0 here, carry 1 here, 1 plus 1, 10, 0 here, carry discarded. Okay, this is the current value of a. If the sign bit of a is 0, you need to set q0 as 1. See here, q0 as 1. So, as the sign bit of a is 0, I have set that q0 as 1 here. Okay. Now, this is q, this is a. Okay. Okay. Now, the third cycle has been over. You need to go for the next cycle. Now, see the sign bit of a. If the sign bit of a is 0, you need to do the shift operation and subtract. See here, if the sign bit of a is 0, you need to do the left shift and subtract m from a. So, now I do the shift operation, left shift. Okay. Okay, left shift operation, this has been discarded. Okay, this is the result of shift operation. Then I need to, as the sign bit of a is 0, I need to subtract. For subtraction, I am adding the 2's complement of m. This is the 2's complement of m we have calculated. Okay, so adding with the 2's complement of m, I am getting this 0 plus 1, 1. Then here 1 plus 0, 1, 1, 1, 1. So this is the result after subtraction. So if this sign bit of a is 1, I need to set again q0 as 0. Okay. Now fourth cycle is over. As we have a 4 bit in the dividend. Okay. So you have to go for 4 cycles. Now all the cycles are over. Now again after completing all the cycles, see they go to the second step. If sine of A is 1, then add m to A. See here, now the sine of A is 1. So what you need to do, take the value of A and add with m. Okay, this is m. So 1 plus 1, 10, 0 here, carry here, triple 1, that is 11, 1 here, carry 1, 1 plus 1, 10, 0 here, carry 1 here, again 1 plus 1, 10, 0 here, carry 1, 1 plus 1, 10, 0 here, carry has been discarded. Okay, now this is the current value of A. Okay, now this A register becomes the remainder, the Q register becomes the quotient. Okay, if the sign bit is 0, no need to perform this operation again. If it is an 1, the sign bit of A is 1, then only you need to find the remainder, you need to add with the m. Okay, the divisor value. Otherwise, no need to do. Then I also show you how to write the 2's complement of the dividend m. So the original m value is 1000. Okay. Then what is the 1's complement of m? That is 0111. So what is the 2's complement? So with 1's complement, you need to add 1 in the LSB. That is 0, 1, 0, 0, 1. Sorry, this is not the, this is the, this is not m. The m is equal to 0, 0, 0, 1, 1. Okay, so you write the 1's complement, that is 1, 1, 1, 0, 0. Then you add 1 in the LSB to calculate the 2's complement, 1, 0, 1, 1, 1. That is the 2's complement of m. So this is the way of calculating m. This is not m. Okay. But anyway, you can take, this is the example for converting that binary number into 2's complement value. Take any binary number 100, then we have done this. So first write the invert value. Okay, then add 1 in the LSB, it gives the 2's complement for that binary number. So this is one example. Now you take the value of m, that is 00011. Okay, first take the 1's complement, 11100, add 1 in the LSB, that 0 plus 1, 1, 0, 0. So it is the 2's complement of m that we have used here. Okay, now you go see the circuit again. See here, first we do check the sign bit of A. If the sign bit is 1, we need to perform the, if the sign bit is 1, we need to perform the add operation. So depends on this bit, the control sequencer gives the add signal here. And if it is 1, so it set this, the control sequencer set this quotient, I mean set this as 0. Okay, so depends on this sign bit, the control sequencer performs the operation or add or subtract and setting the LSB Q0 bit of Q. Okay, thank you.